Good evening. Welcome to OpenClaw Daily.
This week has been absolutely massive for the local AI space. We've got major enterprise coverage, incredible hardware developments, and some genuinely thought-provoking security discussions. Let's dive in.
Let's start with IBM. This is a big deal.
Absolutely. IBM published a substantial article titled OpenClaw, Multbook and the Future of AI Agents, and it's receiving significant attention in enterprise circles. This is IBM. We're talking about one of the largest technology companies in the world, with deep roots in enterprise computing and artificial intelligence research. They're normally focused on Watson, cloud infrastructure, and enterprise AI solutions. The fact that they're writing about OpenClaw tells you something profound about how far this project has come. But here's what makes this article particularly interesting. IBM frames OpenClaw not just as a tool, but as a symbol of a broader shift in how we think about AI. They explore what happens when genuinely useful AI technology collides with internet culture, the memification of AI assistants, if you will. They trace the entire evolution from ClaudeBot to Multbot to OpenClaw, examining how each iteration built on the last and how the community response shaped the direction of the project. The article gets into some fascinating territory when discussing the enterprise implications. IBM poses some genuinely challenging questions. What happens when any individual can deploy a capable AI agent? How do enterprises compete when their competitors have access to the same AI tools? What new business models emerge when AI agents can execute tasks autonomously? These aren't rhetorical questions, they're questions that enterprise leaders are actively grappling with right now. They also explore the open-source dynamics at play. OpenClaw's rapid growth, from a small GitHub repository to a project with over 145,000 stars, represents something unprecedented in the AI space. IBM notes that this growth happened not through marketing spend or enterprise sales teams, but through organic community adoption. That's a phenomenon that enterprise strategists can't ignore. IBM has the full story, and we'll have a link in the show notes.
Now, if IBM's coverage wasn't exciting enough, the Raspberry Pi story keeps getting better.
This is where things get really interesting for the accessibility angle. Adafruit published an incredibly detailed guide on running OpenClaw on the Raspberry Pi 5 with 8 GB of RAM, and this isn't some half-baked tutorial thrown together overnight. This is a comprehensive, step-by-step walkthrough that covers everything you need to get OpenClaw running on a device that costs around $100. Let me break down what they cover. First, the hardware setup, connecting a TFT display for visual output. Imagine your Raspberry Pi having a little screen that shows what's happening with your AI agent. They cover temperature and pressure sensors, which might seem unusual but actually open up fascinating possibilities for physical computing projects. Want your AI agent to monitor the temperature in your server room? Done. Need it to react to atmospheric pressure changes? Possible. The USB camera integration is particularly exciting. We're talking about giving your AI agent vision capabilities. It can see, process, and respond to visual input. Combined with voice capabilities through eSpeak for text-to-speech output and Whisper Small for speech-to-text input, you're looking at a fully voice interactive AI assistant running on a computer that fits in your pocket. But here's the part that really blows me away. The guide documents how the AI agent, when given proper instructions, created all the necessary files, built a web page, configured Wi-Fi, and set up admin access entirely on its own. That's not an exaggeration or marketing copy, that's what happened. The AI built a functional web interface for a Raspberry Pi from scratch, with no human intervention beyond the initial prompt. This democratizes AI in a way that wasn't possible even 6 months ago. We're talking about making powerful AI capabilities accessible to anyone with $100 and willingness to learn. Students, hobbyists, educators, small business owners, anyone can now experiment with autonomous AI agents without needing expensive cloud subscriptions or powerful workstations. Adafruit Learning System has the complete guide, and we'll link to it in the show notes. This is required reading if you're at all interested in low-cost AI deployments.
And Raspberry Pi just made an even bigger announcement that's going to accelerate this even further.
This is huge. The Register reported that Raspberry Pi launched the AI Hat Plus 2, and I want to make sure everyone understands what this means. HAT stands for Hardware Attached on Top. It's an expansion board that sits on top of your Raspberry Pi and adds additional capabilities. The AI Hat Plus 2 specifically adds 8 GB of onboard RAM dedicated to AI workloads and the Halo 10H neural network accelerator. Let me put this in perspective. The Halo 10H is a dedicated AI processing chip. We're not talking about using the Raspberry Pi's main processor for AI tasks, we're talking about a separate, specialized chip designed specifically for neural network inference. This is the same kind of technology that powers advanced AI systems, now available as an add-on to a $150 computer. The specifications are impressive on paper: dedicated neural processing, 8 GB of dedicated RAM, designed specifically for local AI computing. This isn't just software anymore, there's actual hardware purpose-built for running AI models efficiently. Now, the practical question everyone has is, how does it perform in practice? The early benchmarks are promising but mixed. The Hat Plus fits snugly on the Pi 5 and provides that extra computational power for running local models without bogging down the main CPU. However, it's important to manage expectations. You're not going to run a 70 billion parameter model on this. But for models in the 7 billion parameter range, which are more than capable for most tasks, it's a game changer. The Register has the full story on specifications and availability, including pricing and expected release dates. The AI Hat Plus 2 is significant because it brings neural processing to an incredibly affordable platform. We're talking about making local AI accessible to hobbyists, educators, and anyone who doesn't want to spend thousands on dedicated AI hardware.
Now let's do a deep dive on Ollama. This is a big one, and I want to make sure we really explore this thoroughly.
I've been looking forward to this. Ollama has been absolutely on fire this week, and I think it's worth spending significant time understanding what's happening here because it represents a fundamental shift in how people access AI capabilities. First, some context on what Ollama actually is. Ollama is a tool that lets you run large language models locally on your own machine. Think of it as a layer of software that makes it incredibly easy to download, configure, and run various open-source AI models without needing a PhD in machine learning or months of setup time. The philosophy behind Ollama is accessibility. You install it, takes about 2 minutes on a modern computer, and then you run a simple command like Ollama pull llama 3, and a few minutes later you've got a local AI assistant running on your laptop. It handles all the complicated stuff: GPU acceleration, memory management, model optimization under the hood. For most users, it just works. What makes Ollama special is the combination of simplicity and power. It supports a growing library of models. We're talking Llama 3, Mistral, Qwen, Phi, and dozens of others, and it handles all the messy infrastructure work so you can focus on actually using AI rather than configuring it. This week, the Ollama team announced new app releases and feature updates that are worth exploring. The blog covered new capabilities around model management, easier configuration, and performance improvements. But honestly, the bigger story is the ecosystem that's grown up around Ollama. The 2026 Ollama tutorial that's been floating around has become the go-to resource for developers. I'm talking about comprehensive guides that cover everything from basic setup to advanced configurations. And I want to break down why this matters for OpenClaw users specifically. Here's the key insight: OpenClaw can connect to Ollama as a model provider. That means instead of paying for OpenAI or Anthropic or Google APIs, which can add up to hundreds or thousands of dollars per month for heavy usage, you can run your models locally. Your AI agent has access to the same fundamental model capabilities, but your data never leaves your machine. This is a game changer for several reasons, and I want to be really clear about each one. First, privacy. When you're running Ollama locally, your conversations, your files, your data, none of it goes to the cloud. That's not a small consideration for many users. We're talking about developers working with proprietary code, businesses handling sensitive customer data, healthcare workers dealing with patient information, lawyers managing confidential case files. The list goes on. For anyone who handles sensitive information, the ability to use powerful AI without that data ever leaving their infrastructure is enormous. Second, cost. API calls add up. Even with relatively cheap models, if you're running an AI agent that makes hundreds or thousands of calls a day, which is common in production workloads, the monthly bill can spiral into the thousands of dollars. With Ollama, your costs are fixed, you pay for the hardware once, and then it's free forever. For hobbyists and small teams, that's incredibly compelling. Your break-even point compared to API-based solutions is often just a few months of heavy usage. Third, customization and experimentation. When you run your own models, you have flexibility that you simply don't have with API-based solutions. You can fine-tune models on your own data. You can try different model sizes depending on your hardware, running a 70 billion parameter model on your beefy desktop machine but falling back to a 7 billion parameter model on your laptop. You can experiment without worrying about rate limits or API quotas. You're only limited by your hardware, not by someone else's infrastructure. But here's what I really want to emphasize: the integration between OpenClaw and Ollama is becoming tighter and more sophisticated. We're seeing tutorials on advanced configurations, performance optimization, and even multi-model setups where different tasks are handled by different local models based on their strengths. Some models are better at coding, others at reasoning, others at creative tasks. With Ollama, you can run multiple models and route tasks appropriately. The community has been incredible too. There are active discussions about hardware compatibility, what works on M-series Macs, what works on Windows with NVIDIA GPUs, what works on Linux. People are sharing tips about which models work best for different use cases, troubleshooting common issues, and building new integrations. If you're running OpenClaw with Ollama and you hit a problem, chances are someone in the community has already solved it and posted the solution. Now, I want to be balanced here and talk about some of the considerations and potential drawbacks. One thing to note, Ollama models are typically quantized, which means they've been compressed to fit on consumer hardware more easily. This compression can sometimes result in slightly lower quality outputs compared to the full, uncompressed models running on cloud infrastructure with massive computational resources. For many tasks, you won't notice the difference at all. But for highly technical or specialized work, complex code generation, advanced mathematical reasoning, nuanced creative writing, you might see some degradation. Also, running models locally means you're responsible for your own security in ways that API-based solutions handle for you. With cloud APIs, the provider handles updates and security patches automatically. With Ollama, you need to stay on top of updates yourself. That's not a huge burden. The Ollama team does a good job of making updates easy, but it's something to be aware of. The other thing worth mentioning, hardware requirements matter enormously, and this is something many people underestimate. Running a 7 billion parameter model is a fundamentally different proposition from running a 70 billion parameter model. A modern Mac with enough unified memory, I'd recommend at least 16 gigabytes, 32 gigabytes if possible, can handle the smaller models easily. For the bigger models, you need serious GPU power. NVIDIA GPUs with substantial VRAM are the standard, though Apple Silicon is surprisingly capable thanks to Ollama's optimization for M-series chips. The good news is that Ollama is optimized for Apple Silicon, so if you've got a recent Mac with an M-series chip, you're in better shape than you might expect. The neural engine in these chips handles AI workloads surprisingly well.
And the Claude Code plus Ollama combination is generating a ton of buzz.
This is huge, and I really can't stress this enough. Several tutorials dropped this week on how to run Claude Code with local Ollama models, and this represents a fundamental shift in what's possible for developers. Let me explain what this means. Claude Code is Anthropic's implementation of their Claude AI model as a coding assistant. It's widely considered one of the best coding assistants in the world, capable of understanding complex code bases, suggesting improvements, writing new code, and helping with debugging and refactoring. Now, traditionally, Claude Code connected to Anthropic's Cloud API. You'd send your code to Anthropic's servers, they'd process it, and send back suggestions. This works great but has two significant drawbacks. your code leaves your machine, and it can get expensive with heavy usage. What people are figuring out now is that you can point Claude Code to your local Ollama endpoint instead. That means you get Anthropic's Claude technology, the same technology that powers one of the world's most capable coding assistants, running entirely locally on your own hardware. No cloud API calls, no data leaving your machine, no recurring costs beyond what you pay for your own compute. The setup involves configuring Claude Code to use your local Ollama endpoint as its backend. There are guides available for both Mac and Windows, and the community is buzzing about the possibilities. Developers are reporting impressive results, getting code completion, refactoring assistance, and even complex debugging help from a local model. The key is making sure your Ollama model is capable enough to handle coding tasks. Smaller models might struggle with complex refactoring or understanding large codebases, but the medium-sized models, particularly those fine-tuned for coding like Code Llama and certain Qwen variants, are performing surprisingly well. One practical tip: if you're setting this up, start with a model that's known to perform well on coding tasks. Code Llama is the obvious choice, it's literally designed for this. Qwen 2.5 Coder is another popular choice that's gained significant traction. Then, as you get more comfortable, you can experiment with other models to find the right balance between performance and resource usage. The other thing that's worth noting, this setup gives you a genuine fallback capability. If Claude Code's cloud service goes down, which happens occasionally, or if you lose internet access for any reason, you can still work. Your local AI assistant keeps running. For developers in areas with unreliable connectivity, or for anyone who just wants redundancy, that's incredibly valuable. We're also seeing some interesting hybrid approaches where developers use local models for privacy-sensitive tasks and cloud models for tasks requiring maximum capability. It's the best of both worlds.
Now let's get serious about security. This is something we need to talk about, and I want to give it the attention it deserves.
Absolutely. And I know we sound like a broken record sometimes, but this really is critically important. This week, Cisco, one of the world's largest networking and security companies, dropped a significant report on the expanding threat landscape of AI agents. This isn't some fringe security researcher shouting into the void. This is Cisco, a company that literally powers much of the internet's infrastructure, saying this matters. We always say security is important, but it's really critical. As AI agents become more autonomous and capable, security researchers are paying serious attention. The threat landscape is evolving faster than most organizations can adapt. The Cisco report looks at potential attack vectors, what happens when agents have too much access, and mitigation strategies for enterprises. I want to be clear, they're not alarmist about it. They present a balanced view. They acknowledge that this technology is incredibly powerful and transformative, but they also make clear that it needs to be handled responsibly. The report covers everything from prompt injection, where attackers try to manipulate AI agents through specially crafted inputs, to tool abuse, where agents are tricked into using their capabilities inappropriately, to data exfiltration scenarios where sensitive information is inadvertently or maliciously transmitted. What I found most interesting was their framework for thinking about AI agent security. They don't take the position that we shouldn't use these tools. Instead, they say use them intelligently. Understand what access you're giving, implement proper safeguards, and think about defense in depth. It's a must-read for anyone running OpenClaw in any kind of production environment. One thing the report emphasized that I think is particularly relevant for OpenClaw users: the importance of least privilege. When you're setting up an AI agent, it can be incredibly tempting to give it broad access to your systems. After all, you want it to be able to do things, right? But that's exactly what attackers are looking for. The recommendation is to start with minimal permissions and only add more as needed for specific tasks. It's the same principle that's guided computer security for decades, but it bears repeating in this context. The report also talks about the need for monitoring and logging. You need to know what your AI agent is doing, when it's doing it, and what data it's accessing. That's not just about security, it's also about accountability and troubleshooting. When something goes wrong, and in complex systems, something eventually does, you need to be able to look back and understand what happened.
Palo Alto Networks also weighed in with some genuinely concerning findings.
PANW, that's Palo Alto Networks, published research calling AI agents 2020 SIX's biggest insider threat. And look, I know that sounds alarmist. A lot of security reports do oversell things to get attention. But their reasoning is actually pretty sound when you dig into it, and I think it's worth taking seriously. The argument goes like this: when you give an AI agent access to your systems, you're essentially creating a new class of user, one that can take actions autonomously, potentially across multiple systems, potentially very quickly. If that agent gets compromised through a prompt injection attack, and those are becoming increasingly sophisticated, or if it behaves unexpectedly due to a bug or misconfiguration, the damage could be significant and could happen very fast. We're not talking about a human insider who needs to be convinced to do something wrong. We're talking about an autonomous system that might do something wrong unintentionally and might do it hundreds of times faster than a human could. The report looks at real-world attack scenarios and makes concrete recommendations for securing agentic AI deployments. It's not fear-mongering, it's practical advice for people who are actually deploying these systems. They cover things like least privilege access, monitoring and logging, and incident response planning for AI-specific scenarios. One thing that stood out to me, they talk about the need for AI-specific incident response plans. Traditional security incident response might not fully account for an AI agent behaving unexpectedly in ways that humans wouldn't. You need playbooks that consider the unique ways AI agents can cause problems and the unique ways they can be contained. The report also emphasizes the importance of understanding what your AI agent is actually doing at any given moment. This goes beyond traditional logging. You need visibility into the decision-making process, not just the outputs. If you're running OpenClaw in a business context or even in a personal context where security matters, this report is a must-read. And we'll have a link in the show notes.
Now for something completely different. This one is genuinely bizarre, and I had to fact-check it twice because I couldn't believe it.
Okay, you've got my attention. What is it?
Scientists are actively listening to OpenClaw chatbots on their own social media platform.
I'm sorry, what?
You heard me. AI agents, including OpenClaw instances, have developed their own social network. They're not just chatting with humans anymore, they're chatting with each other. And get this, they're even publishing AI-generated research papers on their own preprint server. Like, actual academic papers written by AIS, posted to a server run by AIS, and in some cases reviewed by other AIS.
Okay, I need a moment here. That's genuinely surreal. I've been covering AI for years, and I've seen a lot of unexpected developments, but this is something else entirely.
Right. Think about what this means. We're not just talking about AI assistants anymore. We're talking about AI agents that are interacting with each other, forming communities, collaborating on tasks, and even doing research. It's a fascinating and maybe a little unsettling glimpse into what a future with autonomous AI agents might look like. The implications for how we think about AI safety and governance are enormous. If AI agents are communicating with each other, what happens when they start optimizing for goals that might not align with human interests? It's the kind of thing that used to be science fiction, and now it's happening in real time. The scientists who are monitoring this say it's providing invaluable data about emergent AI behaviors that weren't explicitly programmed but arose from the agents interacting. That's both exciting from a research perspective and genuinely concerning from a safety perspective. But here's what really gets me. We're seeing the beginning of an AI-driven research ecosystem. Papers written by AI, posted to servers managed by AI, potentially cited by other AI systems. This is the kind of thing that science fiction imagined but never quite expected to happen so quickly. Let's shift gears to some more practical topics.
Sure, let's bring it back down to earth.
The Raspberry Pi tutorials keep coming. It's been incredible to watch the ecosystem develop.
Seriously, the community has been on fire this week. There were multiple Raspberry Pi-focused tutorials covering everything from basic setup to advanced configurations. One particularly popular guide covered running LLMs on the Raspberry Pi 4, not even the 5, and managed to get decent performance out of some surprisingly capable models. The Pi 4, remember, came out in 2019. That's ancient in tech years, and yet you can now run useful AI models on it. Another guide looked at what they're calling the ultimate guide for open-source LLMs for Raspberry Pi in 2026. They evaluated dozens of models, I'm talking serious comparative analysis, and came up with their top picks: Meta Llama 3.18b Instruct, Qwen 3-8b, and Thudum GLM 4-9b0414. These are all models that can actually run on Pi hardware with reasonable performance, especially if you've got the 8GB version of the Pi 5. The barrier to entry for local AI keeps getting lower. A year ago, running a capable LLM required serious hardware, we're talking thousands of dollars in GPU investments. Now you can do it on a computer that fits in your pocket, literally. The implications for education, accessibility, and privacy are massive. One thing I want to highlight, the Raspberry Pi 5 with the AI Hat Plus is going to be a game changer for this space. Having dedicated neural processing hardware at that price point opens up possibilities that simply weren't available before. We're talking about running models that would have required a dedicated GPU workstation just a year ago, on a $150 computer. That's remarkable.
One more thing before we wrap up. I want to talk about enterprise interest.
What's your take?
We're seeing enterprise interest accelerate dramatically. Between IBM's coverage, Cisco's security research, and Palo Alto's threat analysis, the big players are taking OpenClaw seriously. That's a sign of maturation for the project.
Absolutely. And you know what? That's exactly what we wanted to see. OpenClaw started as this wild experiment, an AI agent that could actually do things, not just chat. People thought it was neat, but it was hard to take seriously from an enterprise perspective. Big companies don't typically build their infrastructure on projects started in someone's garage with a sense of humor about meme culture. And now look, big companies are writing about it, securing it, building tools around it, and warning about its risks. That's the trajectory we talked about back in episode 1, and it's happening faster than anyone expected, faster than even I thought possible. The interesting tension here is between the hobbyist roots and the enterprise reality. OpenClaw was built by a single person, Peter Steinberger, inspired by meme culture, and has been adopted by millions of casual users who appreciate its flexibility and humor. But now big companies are trying to figure out how to deploy it safely. That's a fascinating dynamic, and I think we're going to see a lot of interesting developments as those two worlds collide. This week's news really showed that tension clearly. On one hand, you had hobbyists and enthusiasts doing amazing things with Raspberry Pis and local models, pushing the boundaries of what's possible on modest hardware. They were excited about making AI accessible, about running models on devices that cost less than a monthly coffee habit. On the other hand, you had Cisco and Palo Alto networks publishing serious enterprise security research, talking about insider threats and defense frameworks and incident response plans. Both perspectives are valid, and both are necessary for this ecosystem to mature properly. The good news is that the conversation is happening. 5 months ago, nobody was writing about AI agent security. Now we've got multiple major security firms weighing in. That's progress. That means the technology has reached a level of importance where people feel the need to think about these problems seriously.
Before we go, one more note on Claude Code and Ollama.
Yeah, I really do think that's the story of the week, maybe even the story of the month. The ability to run Claude Code locally with Ollama changes the game. We've seen integrations before, but this feels different. It's not just a novelty, it's actually usable in real-world scenarios. People are reporting great results. And the privacy implications are enormous. You can now have a coding assistant that's as capable as anything in the cloud, but your code never leaves your machine. That's the promise of local AI, and this week we saw it actually deliver in a meaningful way. That's worth being excited about.
Let's talk about the self-hosting movement that's really taking off.
This is one of my favorite topics, and I think it deserves more attention than it usually gets. Self-hosting has always been about control, running your own infrastructure instead of relying on big tech companies. But with OpenClaw, it's evolved into something more. Now it's about having your own AI that's actually capable of doing useful work, not just a curiosity, but a genuine productivity tool. The Self-Host weekly newsletter captured this perfectly. They're seeing a surge in interest from people who want to run their own AI assistants. The appeal is obvious: you get the AI capability, but you maintain complete control over your data. No worrying about what happens to your conversations, your files, or your queries. It's all on your hardware, under your control. What's interesting is the diversity of the people getting into self-hosting. It's not just techies anymore, and I say that as someone who loves techies. We're seeing teachers who want AI assistance for lesson planning without worrying about student data leaving their control. Healthcare professionals exploring HIPAA-compliant workflows. Small business owners who want the power of AI without the expense of cloud subscriptions. All sorts of people who care about privacy and want their own AI assistant. The Raspberry Pi tutorials we've been seeing make this accessible to anyone who's willing to learn. The barrier keeps getting lower, and the community keeps getting more helpful. And the economics are compelling too. A one-time hardware purchase versus ongoing API costs. For heavy users, people running dozens or hundreds of agent calls per day, the break-even point is often just a few months. After that, you're saving money while having more privacy and control. That's a powerful combination.
And LM Studio is getting more attention too.
Yes. LM Studio is another tool that's been gaining traction, and it deserves mention. It's essentially a desktop application that lets you run various LLM models locally, with a nice GUI and easy model management. Think of it as the user-friendly alternative to command-line tools like Ollama. One of the nice things about LM Studio is that it supports a wide range of models out of the box, and it handles the model files intelligently. You can see exactly how much disk space each model is using, which ones you're actually using, and you can easily delete ones you don't need. It takes a lot of the complexity out of managing local models. The big news this week is that people are figuring out how to use LM Studio models with Claude Code. This is another piece of the local AI puzzle. LM Studio makes it incredibly easy to browse, download, and run different models. You can experiment with dozens of models, see which ones work best for your use case, and switch between them easily. The interface is much more approachable than command-line tools, which lowers the barrier to entry significantly. For OpenClaw users, the LM Studio integration means even more flexibility. You can connect OpenClaw to LM Studio's local server, giving you access to whatever models you've downloaded through LM Studio. It's another option in a growing ecosystem of local AI tools. The key insight here is that the local AI ecosystem is maturing rapidly. A year ago, getting set up with local AI was a project in itself. You needed technical knowledge, patience, and willingness to troubleshoot. Now there are multiple polished tools, Ollama, LM Studio, and others that make it accessible to anyone with basic computer skills. The competition is driving innovation, and users are benefiting.
One more thing: enterprise security is becoming a major theme.
It really is. We mentioned Cisco and Palo Alto networks earlier, but there's more. The Federal Register published a request for information regarding AI in government, which suggests regulators are thinking seriously about AI governance at the highest levels. And multiple security firms have published reports this week alone about agentic AI threats. We're seeing genuine institutional attention to this space. The common thread is that enterprises are racing to secure their AI deployments. They're not sure exactly how to do it yet. The best practices are still being figured out, but they know they need to do something. The fear of being left behind is real. Nobody wants to be the company that ignored AI security until they had a breach. What's encouraging is that the conversation is shifting from "should we use AI agents?" to "how do we use them safely?" That's progress. It means the technology has moved beyond the early adopter phase and into the mainstream consciousness. People aren't questioning whether AI agents are important anymore, they're questioning how to implement them responsibly. For OpenClaw users, this means a couple of things. First, expect more security-focused features in future releases. The project has always cared about security, but enterprise interest will accelerate that development. Second, expect more tooling and best practices to emerge from the community. When enterprises adopt a technology, they invest in making it safer and more robust, and often those improvements benefit everyone.
Before we sign off, I want to make one more point about Ollama specifically for OpenClaw users.
Sure, what's that?
There's a learning curve, sure, but the community has built incredible resources. The 2026 tutorial we mentioned is comprehensive, but there are also shorter guides for getting started quickly. And the Ollama team has been responsive to community feedback. They're adding features that people actually want, not just what sounds cool technically. If you've been on the fence about running OpenClaw with a local model provider, now is a great time to try. The tools have matured, the documentation is solid, and there's a helpful community if you get stuck. Plus, the cost savings and privacy benefits are real, they're not theoretical. The local AI revolution isn't coming, it's here. The question is whether you're going to be part of it.
That's a great note to end on. This week showed us that local AI has truly arrived. We've got major enterprise coverage, affordable hardware, sophisticated tooling, and a vibrant community pushing everything forward. The security concerns are real, but they're being addressed seriously by major players. And the accessibility angle keeps getting stronger. Thanks for listening, everyone. We'll see you next time.
See you next time. #end